we're going to have a look now at physics topic by topic. We're going to look at potential difference and resistance, and this is one of those core practicals, a common sort of practical type of exam that we do to have a look at and make sure how things work. So what we're going to do in this session is we're going to look at how the resistance of a wire depends upon its length, and after a lot of effort of trying to get wire set up and not finding various bits and pieces, we've got it all set up. So our circuit that we're going to try and do is going to look very much like this. We've got a couple of cells, and to one end I'm going to attach a probe. And to the other side we've got a ruler, and clamped to this I have a piece of wire. Clamped to that wire we've got a bulb, an ammeter, and across here we've got a voltmeter. So what we're going to do is we're going to put this little nail down on the piece of wire. That's going to complete the circuit, and what we're going to be able to do is measure the voltage and the current as we move this down the ruler. So I'm going to want here a little table. I'm going to try and draw out. We're going to record the length, and for that length we're going to record the voltage. We're going to record the current, and we're going to work out the resistance, which we'll measure in ohms, and from that we can then have a look at this to try and draw ourselves a graph of length against resistance. And so we're going to get some sort of graph going along here, and we're going to look at something like the length, the thing we're going to change, and our resistance in ohms. I'm going to see what sort of graph we're going to get. Let's go and have a look at the practical setup for this. And here it is. Right, there's my paper to record. What have we got? We've got coming out of the battery to this device here, and this has just got a sharp point, and this can go onto a piece of wire, and when it does so, it completes the circuit. The circuit comes out of the battery into a bulb, into an ammeter, and a voltmeter, which I'm going to turn so that you can look at them. This is part of the problem that I've had. I'm just going to clamp this to the bench. I'm going to use a piece of blue tack at either end. So hopefully that won't move. Who said lying to you? Let's put a bigger lump of blue tack there. Right, so that's now going to be reasonably secure. So that's not going to move. I've got then a voltmeter, an ammeter and my little probe that can touch the wire, and we can record what we've got. Now I'm going to start at a length of 2 centimeters, because that's the first reading I can practically take with this equipment, and we can record the voltage and the current. So my voltage here is 0.02 and my current is 0.18. I'm going to try and choose where I'm going to do this, so I'm going to try and do this about every 5 centimeters. So at 5 centimeters, it's just about 0.3, isn't it? Yeah, I'm going to call that 0.3. The current's the same. We're going to go at 10. Zero point 0.04, 0.18. Let's go at 15. 0.05. 0.18. We're going to do it 20. 0.06. The current doesn't seem to be varying much. We're going at 25. 0.07. We're going at 30. And again, 30 is about the same, 0.07. 35. We've got 0.08. 40. And 0.1. 45. 0.11. 50. 0.12. We don't want the wire to get really hot. I'm actually only putting 3 volts through this. .55. 0.1. Make sure. 0.13. 60. Just about coming out of range on the camera now. My cameraman went off. And that's going to be 0.14. 65. 0.15. We're seeing some consistency here in the rate of movement. 70. 0.16. 75. 0.17. 0.17. We can manage 80, 0.18 and 0.18. 85, and we can almost predict what some of these seem to be doing. I'm going to get to 90. And I can do my last one effectively at 95. So there's our first experiment done. I want to repeat this experiment, but this time I want to use different wire. So this is relatively thick wire. So, don't know if we can see that, I'll position that. So it's quite thick wire, this. Focus on my finger, if you can. Yeah, I can see it's quite thick wire. Now I'm going to try it again, this time with much thinner wire. Let's put up a comparison. If you can focus on my hand, there we are. Thick wire and much thinner wire. We're going to try the thinner wire now. So I'm just going to get my thick wire out of the way, and we'll try some thinner wire. And we'll clamp it into place. So there's my thin wire. So we're going to try and repeat this with thinner wire, and that should give us a little bit of difference. So I've got this set at as near to 1 as I can. And let's see what we get. So I'm going to set up a new table of data. So let's draw up my new table. And again we're going to put in the same thing. We're going to have the length, we're going to have the voltage, we're going to have the current and the resistance. So let's have length, voltage, current which we're measuring in amps, resistance we're measuring in ohms, and this time we're doing it with the thin wire. Now the wire I'm using is actually called Eureka wire, so in theory it's got a reasonable resistance. We'll have a look and see what we can do. Okay. We're ready to go. We're going to start at 2 centimeters because that's the best I can do. And this time we've got 0.14. and the current was again this time 0.18. Let's do these at different distances then. 5 centimeters is 0.13. 10 centimeters, 0.18. 15 centimeters, 2.1. 20 centimeters, 0.23. 25 centimeters, 0.29. Let's go 30 centimeters, 0.33. Difference between live and doing this recorded, of course, is recorded I'd do a couple and then put all the rest in for you. This way I've got to do the whole lot. 0.37. 40.41. 45, 44, 0.17. This side on 17. I'm going back checking all of these because I've got now currents of 0.17 on all of them. Whereas I thought I started on 0.18, I did. 0.18 and going down to 15, that's 0.17. I didn't read those carefully. Right. I was concentrating on one bit, 50. Here 0.47 and 0.16. .44 I've got now, and 0.15. 0.46, yeah, 0.46 and 0.16. 55, 5016. This time 60. 0.56. 65. 0.57. So we've got a similar sort of thing going as we had before. And then we've got here. .56. I'm not really happy with 70. Let's just take that one again. It's getting good contact. That's better. I'm happy with that. 5.8. 75. .63, and this time 16. .6, .63. We'll call it. 80, nearly there. And we've got 0.66, 0.15, 85, yeah, my cameraman are not paying attention here. Put this at 85, 0.69, 0.15. Do two more. 90, 0.74, and our final one at 95.73, which is different than what I'd expect. What I've got to get is make sure that this knife only touches the wire, it doesn't touch the rest. Some 3. And there's my second set of values. Okay, let's go and see what we can do with these. Now, I'm not going to try and plot every one of these because that's going to take way too long. So let's just take a few of these values and see what we get. So let's try these. So we know for working out the resistance that V equals IR. So our resistance that we want to calculate is going to be the voltage divided by the current. So let's try a few of these numbers and we'll see what we get. So if I call up my calculator, then if I do the 10th value, this is going to be my voltage, which is going to be 0.04 divided by 0.18, and that's going to give me horrible number 0.22. Let's try a value perhaps of 40. So this is going to give me we've got a value of 0.1 over 1.8. That's going to give me a value of 5.555. let's try something like about on this about 65. And that's 0.833. And we'll try perhaps somewhere near the end. Let's go for 90, which is 2 over 0.8. Which is going to give me 1.11. Now, let's have a look at what this graph is going to give me. So let's plot a graph. And I've got to go from 0.2 up. So let's try my resistance and my length. So let's just try my length like this. So that's going to give me 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And my length is going to go from didn't quite give myself enough room. Shame. 2, 4, 6, 8, 10. 1.2, 1.0, 0.8, 0.6, 0.4, 0.2, and we've got 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So this is our length, this is our resistance measured in ohms. Right, okay, it will do for 1 watt. So if I take my first values here, that at 10 centimetres I've got 0.2, at 40 centimetres I've got about 0.55, at 65 centimetres I've got 0.83, and at 90 centimetres I've got about 1.11. And let's see if that's going to fit on a straight line. And pretty well that does. I could take far more values and put in there, and in a real test that's what I try and do. And that was the thick wire. On the same graph maybe we'll try, but I don't know, it depends what these values are going to be. We're going to look at what the thin numbers are. So let's just take 10, 30, 50, 70 and 90. Let's just take those values and see what we get. So let's have a look. This is 0.8 over 0.8. Well, I'm not even bothered with the calculator for that one. Well, that's 0.7 really was, so yeah, we will have to do that. So, looking at the calculator here, I've got over 0.7, and this is 0.8. So this is 0.18 over that, and that's going to give me 1.058. So 1.05. I'll write 8 down there for convenience. Right, my next one, 0.33 over 0.17, because I got my values wrong, which I wasn't looking at. So that is going to be my 0.17. So let's put that on here. And we're on 0.33. And that's going to give me 33 over 17, no use to me, 1.94. For our 50 centimetre length, 0.46 over 0.16. So 0.46. It's going to give me 2.875. Doing our last ones now, we've got 0.58 over 0.15. Bit too keen. I said it was 0.58. And that was 3.86. And my last number is 0.74 over 0.15. Gives me 4.93. Let's take those values and we'll plot those on a graph. So I'm running from my values of about 0.1 up to down here 0.5. So 1 to 5. And we'll draw these in. Okay. As you can see, I'm just doing a very quick sketch of a graph just to give you an idea of what's happening. And we'll take an approximation of what we've got. So I've got my 10, 20, 30, 40, 50 and so on. And on the bottom you would do far more values for this, and we can take my readings. So at 10 I've got 1. This is how inaccurate I'm doing. At 30 I've got just about 2. At 50 we've got nearly 3. At 70 we've got nearly 4. And at 90 we've got nearly 5. perhaps not such a good graph this time. And I'm going to use my best fit here, which is going to be something like about this. This part of the ruler is actually quite good for doing best fits. You can buy best fit rulers and they work really quite well. And we've got an approximation here for a straight line. I've done the experiment very quickly. And if I wanted to plot the other one on the same value, then we're only going up to 1.2 at 90. So we could see if we had them on the same graph, then the lines would be something like this. And I plotted 1 point there. But what we can see is there is a linear relationship. What we can see is that basically as we increase the length, so the resistance also increases. And for our equations working out, we've worked out that our resistance equals the voltage over the current. I remember this as V equals IR. I find it easier to remember that. And then, because I'm reasonable at maths, I can then rearrange this formula to remember all the other ones. If you can't do this, then you basically need to remember these three different ones so you can work them all out. Let's go back to our experiment and have a look at this a different way. And what we can do is we can plot a different type of graph. We can do a current versus a potential different graph. So we measure current on one and volts on another. So what we're going to try and do is we're going to try to produce a graph which is going to have my current on this side and my voltage on that side, and we're going to try and see whether it's a straight line or not. Let's go and have a look at how we set the experiment up.
At the moment our experiment's all set up as we had it before, so I'm going to take it all to bits. I'm going to get rid of my little pen and we're going to take all of this to bits. And I don't need my ruler with its fancy end anymore. And we're going to look at instead a variable resistor that looks something like this. I'm not going to use a bulb in here either. The bulb was just to show that we had electricity flowing. In this case, this resistor works with the electricity coming in here, and then I can move this along, and then the electricity thinks, well, it's a lot harder going along there. What I can do is I can come out through this large metal rod and out. So let's set up a circuit for this. I'm going to have my battery, get the wires out of the way, connected to the resistor. I'm going to have the resistor down the bottom here connected to my ammeter, and then I'm going to plug in my ammeter to my battery. And what I should see, that as I move this, I should get a change in my current, and you should just be able to see that. Right. Going across here, I'm going to use slightly longer leads, I think, to make life easier. I'm going to take out a feed here to my voltmeter. So I'm going to plug into my volts, and then I've got the wrong lead. I only need a short one, so let's use a short one here. So this is voltage, and now I haven't got my ammeter working. At all. This was some of the problems I was having while I was late starting today. Right, appears to be working. And now, as I move the resistance, you can see the voltage is going up and the current is going down. Now I do have some kit that will actually do this and record this quite nicely, but we're going to do this the hard way, and so I'm going to record some voltages and some currents. And maybe next time we'll do it the easy way and you'll see how this works. Right, so all I need for this is some voltages and some currents, and I'm not going to take many values here. I'm just going to do this very quickly. So let's start off. I've got my voltage. I've got 1.7 against 0.94. Move it along a bit. I've got 2.27 against 0.27. I've got 2.44, 0.09, 2.48, 0.05, 2.5, 0.03, one more, 2.51, 0.02. You'll see that it doesn't make so much difference down the bottom. It makes a lot more difference at the top end. Right, let's just unplug this, save the batteries, and let's go and plot these values.
So a fairly quick and dirty experiment, but hopefully this will give us an idea of what we're doing. So my voltage is going to go here, really, it's only going from 2 to 2.5. So let's draw this one in. Zoom out. So I'm going to put my voltage along the bottom, and I can do this from 0, but it's not going to work that well. Here we are, let's have my current going. Right. So my current is going to go from 0.02 to 0.9. This is going to go, really it's only 2.5, isn't it? So if I call that 1, 2, 3, there's going to be 2.5, 2, 1, there's my 3, and this is going to be my what should we do here? I've got to go up to 2. I've got to go up to 0.1, yeah, so let's have this as, that's going to be 0.9, 8, 7, 6, 5, 4, 3, 2, 1. Right, let's try and see what we got. We've got about 1.5, so 1.7 is going to be about there. 1.7, and it's going to be right in the middle of my 2. Then 2.27 is going to be halfway there, and that's going to be about 0.27, and 2.44 is going to be about 0.9, and we're looking at a graph looking something like this. Which is not what I'm expecting. I was expecting that to go the other way. I was expecting when my volts are 0, my current's going to be 0. But we don't seem to have that. As my volts are going up, so my current here was going down, so that's going down as that's going up, isn't it? That's going up. That's going the other way. I should have done something different. So, boring. That one didn't quite work as I was expecting. Something was going wrong. I'm expecting a graph to look something akin to this. It should go through the origin, and I was having problems with my voltmeter and ammeter earlier, which is why I delayed the start, and it appears that I've got something else going wrong with it again. So, it didn't work. Maybe next time we'll try and get this one to go. So, what we should see is, as the current increases, so the voltage should increase. There's something going wrong somewhere. We'll investigate, and I'll come back next time and we'll see if we can actually get all this sorted and get it working. Sometimes when I do things quickly, I make a simple mistake and something goes wrong. We'll have a look and see. Anyway, until next time, if it was useful, subscribe, and I'll see you in a week. Take care. Bye-bye.